Okay, so we are starting EOT question 5. Can you read the objective? EOT question number 5. Read the objective, please.
Okay, Mr. Differentiate between transverse, longitudinal, and surface waves and give examples.
Okay, transverse waves, differentiate between transverse waves, longitudinal waves, and surface waves. And give examples, right?
Yes.
Okay, give examples. See, longitudinal wave, transverse wave, and surface wave, all types of wave transfer energy, right? What is wave? Wave means wave transfer energy, right? Wave transfer energy without transferring the matter. Okay, a wave transfer energy, waves transfer energy without transferring matter, without transferring matter. Okay, a wave transfer energy without transferring matter. So when wave pass through a medium, for example, if a wave need a medium for traveling, such waves are called mechanical waves. Mechanical waves need a medium for transferring. Electromagnetic waves do not need medium. So whether waves medium, whether a wave need a medium or do not need a medium for traveling, we divide waves into two types: mechanical waves and electromagnetic waves. Mechanical waves means for traveling, for mechanical waves to travel, there must be a medium, a presence of a medium. For electromagnetic waves, no need. If there is a medium, if there is no medium, means vacuum, there is nothing, no air, no water, electromagnetic waves can travel through vacuum. Mechanical waves cannot travel through vacuum. Okay, then transverse waves, longitudinal waves, and surface waves. This is another classification of waves based on the vibration of the particle. For example, when a wave is passing through air, the air particles will vibrate. So how the air particle is vibrating while a wave is traveling through the air? Depending on that, waves are classified into three types: transverse waves, longitudinal waves, and surface waves. This classification is depending on how the particle of the medium is vibrating while wave is traveling through that medium. For example, when sound wave is traveling through water, how the particles of the water, means water molecules, particles of the water means water molecules, particles of air means air molecules. So how the particles in the water, means how the water molecules vibrate when a wave is passing through the water. Based on that, we divide waves into three types: transverse waves, longitudinal waves, and surface waves. So this classification is based on how the particle is vibrating. Okay, this classification is based on how particles of the medium, are vibrating. Depending on that, we classify waves into three types. And whether the wave need a medium or do not need a medium, we can classify waves into two types: mechanical waves and electromagnetic waves. Mechanical waves electromagnetic waves. So this classification is based on whether the wave need a medium to travel or do not need a medium. Means some waves can travel through vacuum, some waves cannot travel through vacuum. If waves can travel through vacuum, they are called electromagnetic waves. Okay, no medium required. Means medium is not a necessary. If there is, it can travel through medium, it can travel through vacuum. No medium required. So here medium is required for traveling. Okay, the next thing, means our objective is this one. How particles of medium, means how the waves are classified based on the mode of vibration of the particles of the medium, and explain transverse waves, longitudinal waves and surface waves. So okay, so in transverse waves, how particles are vibrating. In transverse waves, for example, wave is traveling like this, and if it is a transverse wave, wave is traveling in this direction, and if it is a transverse waves, like waves that we are creating on a rope like this by making it like this, and the energy is transferring in this direction, but the particles of the medium are vibrating up and down. Particles of the medium are vibrating up and down. This type of waves are called transverse waves. In transverse waves, particles are vibrating perpendicular. Okay, particles of the medium are how are they vibrating, students? How are they vibrating? Particles of the medium are vibrating perpendicular, right? How are they vibrating? Yeah, perpendicular to the direction of travel of the wave. Okay, perpendicular to the direction of travel of the wave. For example, we take a rope and we will make like this. One end we will make like this, so that energy is transferring to the other end, while the wave will be like this, right? The waves will be like this. So we will draw the transverse wave like this. We can draw the transverse wave like this. Okay, so what is this part of the wave? This part of the wave is called crest. What about this part of the wave? Trough. So transverse wave consists of alternate crest and trough. Crest, trough, crest, trough, crest, trough, like that. Okay, so example of transverse wave, all electromagnetic waves are transverse waves, and we can make ripples on the water, right? So if we just touch the water like this, slowly touch the water, we can make ripples on the water. Okay, that is transverse wave. And if take a rope, move the one end of the rope up and down, the wave produced in the rope is transverse wave. Then next we will talk about longitudinal waves. For example, when I talk, the sound is traveling like this. For example, the sound is traveling in this direction, so this is the direction of the travel of the wave, and the sound is traveling through air. So these air molecules or air particles will be moving forward and backward. See, sound is traveling in this direction and the air particles moving like this, forward, backward, forward, backward, forward, backward, forward, backward, which means the air particles are vibrating parallel to the direction of travel of the wave. So if the wave is traveling like this direction, along this direction, and the particles are vibrating Forward, backward means to and fro vibration. Forward, backward, going forward, then backward, colliding to the next particle going forward, then backward, colliding to the next particle, like that. Okay. So if the particles of the medium are vibrating parallel, particles vibrating, particles are vibrating parallel. If particles are vibrating parallel to the direction of travel of the wave, such waves are called longitudinal waves. So longitudinal waves we can represent like this. For example, yes, then see, this shows the pressure difference. Okay, pressure difference. When a sound wave is traveling through air, some part of the air will become compressed. Compressed means high pressure region, and some part become low pressure region. Okay, so sound waves create pressure difference in the medium. Every longitudinal wave, sound is a longitudinal wave, every longitudinal wave create pressure difference in the medium or pressure variation in the medium. Some part of the medium become low pressure, some part become high pressure, then low pressure, then high pressure. The region of high pressure is called compression and the region of low pressure is called rarefaction. So this represents compression. Compression means high pressure region, and this represents rarefaction. Compression, rarefaction, compression, rarefaction. So a longitudinal wave consists of alternate compression and rarefaction. Longitudinal wave consists of alternate compression and rarefaction, a series of alternate compression and rarefaction, compression then rarefaction, then compression then rarefaction, like that. Example, sound wave. Sound wave is an example for longitudinal wave. Okay. Surface wave, right? Surface waves. For example, the waves in the deep ocean, like deep water is longitudinal wave. Okay, the water waves in the deep water, like in the depth of the ocean, depth of the lake, that will be longitudinal wave. But on the surface, the particles will be moving in a circular pattern. Okay, particles vibrate or particles move on the, for example, on the surface of ocean, on the surface of the sea, particles move in a circular path. Particles move in a circular path, means it will repeat the circular path. Okay, circular. So we will say move in a circular path. Okay, because vibration means it is like to and fro, right? So here what is happening, particles are moving in circular path. For example, wave is traveling along this direction, the wave is traveling along this direction and the particle is moving along the circular path. The particle is moving along the circular path. So here you can see, when you take this point, the particle is moving up, right? Correct?
Yes.
And when you take this point, the particle is moving down, right?
Yes.
When you take this point, the particle is moving to the right side, and when you take this point, the particle is moving to the left side. So you can see here, at the top and the bottom, the particles are moving parallel to the direction of travel of the wave, right?
Yes.
So we can say at the top and the bottom, it is longitudinal, right? The particles are moving parallel means longitudinal. But here you can see the particles are moving perpendicular to the direction of travel of the wave, right?
Transverse.
So transverse. So we can say surface wave is longitudinal wave plus transverse wave. At some points it is longitudinal, at some points transverse. Here longitudinal, here longitudinal, here transverse, right? So surface wave are longitudinal at some positions, at some points, and transverse at some points. Okay, fine. Example, waves. Okay, water waves on the surface of the ocean. Water waves on the surface of the ocean.